Okay, today we're going to go over how to solve a compound inequality. A compound inequality consists of two inequalities joined by the word and or the word or. To solve a compound inequality, you must solve each part of the inequality. A compound inequality containing the word and is true if and only if both inequalities are true. Example 1, solve and graph the solution set. See how we have two inequalities here, and in between them we have the words and. This is a compound inequality. It's basically like two problems in one. So we're going to solve the problem on the left side first. So we have 2x plus 3 is greater than 7. So to solve this, we would subtract 3 from both sides. Then we get 2x is greater than 4. Then we would divide by 2, And when we divide by 2, we get x is greater than 2. So the first one is solved. And then we're going to break down the word that's joining them, which is and. Now to solve the second one. Negative x plus 1 is greater than or equal to negative 6. So we're going to subtract 1 from both sides. So we get negative x is greater than or equal to negative 7. Then the last step is to remember there's an invisible 1 here. So we're going to divide both sides by negative 1. And remember, when you divide both sides by negative, you have to flip your inequality symbol. All right, so we got it solved. So this is my solution right here. X is greater than 2 and x is less than or equal to 7. Now I want to graph these. I want to graph the solutions. Well, let's look at the first one. Let's look at x is greater than 2. To graph this, we would have an open circle at 2, and x is greater than 2 would be shaded to the right of 2. So it'd be everything to the right of 2. All right, let's graph our second one. X is less than or equal to 7. So we would have a closed dot at 7, and then all the solutions would be everything to the left. Okay? Now, this is a compound inequality. And remember the sentence I gave you up here. Right here. A compound inequality containing the word and is true if and only if both inequalities are true. So what that means is you got to find the solutions that are common to both of these graphs. So where do these two graphs overlap? Well, they overlap, if you look here, right here in this red region. So in those points in that red region will be the solutions that make both the blue one and the green one true at the same time. Okay? So my solution set to this compound inequality would be this graph. An open circle at 2, let me do it in a different color. Let's do it in red. An open circle at 2 and a closed circle at 7. This is the solution. This is the solution to that compound inequality. But these are the points that make both statements true at the same time. So this is your final graph. This is your final solution. These two graphs up here help you determine the final graph. It's where the blue and the green graph overlap. That's how and works. And is where they overlap or where they intersect. Let's look at another example. Let's look at this example. This one looks a little different. This is a compound inequality, but you don't see the word and or in it. Okay? This is a special one. This is a special case. This is actually an and one. Only the and ones can be written like this. You could think of it as two separate ones. You could think of it as negative 23 is less than or equal to negative 3y plus 7. And then it would be joined by and. And the second one would be this one. This part. Negative 3y plus 7 is less than negative 8. So we could do it like we did the first one, where we separate the two and just solve each one individually and then graph the two and see where the two graphs overlap. But there's actually an easier way to do it when it's written like this. So let's see how we can solve this without having to rewrite it twice. Okay? Well, in an equation, you have a left side and a right side. Well, here we have a left side, a right side, and a middle. So instead of having two sides, we got three sides. And you got to focus on the middle, because that's where your variable is located. You're trying to get the variable by itself. So what we want to do is basically, if you could just cover up this part, how would you solve that equation or that inequality first? You would subtract 7, right? But I can't just cover this part up, that's there. So what I'm going to have to do is I'm going to have to subtract 7 on all three sides. So when we do that, we get negative 26 is less than or equal to negative 3y less than negative 15. So now we're again going to focus on the middle. We need to get the y by itself. So what would I do? I'm going to have to divide everything by negative 3. So I'm going to have to divide all three sides by negative 3. So negative 23 divided by negative 3. 3 doesn't go to 26 evenly, so let's just leave it as a fraction, but it's going to be positive. We've got two negatives. Well, what am I doing here? I'm dividing. So what I got to do is I got to flip my inequality symbol. And then these cancel out, you just get y. I'm dividing by negative 3 again. Negative 15 divided by negative 3 is 5. And again, I divided by negative 3, so I got to flip my inequality symbol. Okay? So now, again, this is like two graphs. You can think of it as this. You can think of it as, I like the y first, as y is less than or equal to 26 over 3. And here's the second part. Y is greater than 5. Okay? So let's graph the first one, the red one. We wanted to graph y is less than or equal to 26 over 3. Well, what is 26 over 3 about? It's about 8.6. So it's in between 8 and 9. And it's equal to, so it'll be a closed dot right here. And it would be shaded to the left. So I'll be shading everything to the left. Let's do the green one now. Y is greater than 5. Would be an open dot at 5 and shaded to the right. So if these two graphs were overlapping, or were setting on top of each other, where would they overlap? Let's look. It's in between the numbers 5 and 26 over 3 about. So my final graph look like this. I would have an open dot at 5 and a closed out dot at 26/3, which is about 8.6. And then I would have everything shaded in the middle. Now if I go back and look at what I had up here, move this away, and just look at this. Look here, where's y located? It's in between 5 and 26/3. That's what I got down here. It's in between 5 and 26/3. Another thing you always want to make sure when they're written like this, when they're written as one that has 3 sides, make sure your symbols are always pointing in the same direction and they're always pointing towards the smaller number. If they're not, you did something wrong and forgot to flip the switch or flip the symbol. So that's the and ones. To me, the and ones are easier than the or ones. Because and, you just gotta find the solutions that are common to both. Where do the two graphs overlap? All right, so let's look at an or one. A compound inequality containing the word or is true if one or more of the inequalities is true. All right? So you do it the same way you would do an and one. You get two separate ones, so just solve them separately. So we got k plus 6 is less than -4. So to solve this, we would subtract 6 from both sides. We get k is less than -10. Or, what else is true? Well, now to solve the other one. So this one, we divide both sides by 3. 3 doesn't go into 14 evenly. So we can do that as 14/3. And if we want to estimate what 14/3 is, it's about 4.6 repeating. So about 4 2/3. All right, so let's see how you would graph an or one. Again, let's do the two parts individually first. So this graph, k is less than -10. So k less than -10 would be an open circle at -10 shaded to the left. Now let's graph the green one. This graph k is greater than or equal to 14/3. Okay? So 14/3 is 4 2/3, so that's be in between 4 and 5. And it will be closed out, and that will be shaded to the right. So, since this is an or one, either the blue one has to be true or the green one, though they both can be true. So what you need to do is you got to draw one final graph that has all of the blue solutions and all of the green solutions. You got to draw one graph that has all the blue solutions and all the green ones. So my final graph for the or one would be this. This is my final graph to that equate that in that compound inequality above. I need the blue one in it. And I also need the green one in it. So this is my final solutions, this graph right here.